Alrighty, in today's video, we're going to be talking about rotations. Rotations, we want to be thinking about turning or spinning or all of the above. Now, the three possible rotations that you are going to see are 90 degrees, 180 degrees, and 270 degrees. Now, be careful because we have a clockwise rotation, which means the same direction as the clock, which is what you see over here. But you could also be asked counterclockwise degrees. Counterclockwise degrees would be from the pre-image going the opposite direction of the clock. So 90 degrees clockwise is the same as 270 degrees counterclockwise. 180 degrees clockwise is the same as 180 degrees counterclockwise. That one's pretty easy. And then we have 270 degrees clockwise is the same as 90 degrees counterclockwise. The reason you should probably know these is because if the question ever does give you counterclockwise, everything that we usually talk about is in clockwise rotations. So that way it'll just make it easier for your brain to not get confused. So in order to identify rotations, let's take a look at this very edge corner of this pre-image. So currently this point is at 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 7, 4 is where the corner of my pre-image is. When I turn that 90 degrees clockwise, that viewpoint is all the way down here, which now the coordinate points are at 4, -7. What just happened is those numbers switched places. So my original xy is now yx. What also happened is my x value, the 7, switched to a -7. So it has changed. Algebraically, a way that we show change is by adding that negative symbol in front of our algebraic expression. Going back to this first point, if I rotate 180 degrees, this would now be the corner, and my new ordered pair is at -7, -4. Notice how this time my x and y values did not switch because the 7 is still in the x place and the 4 is still in the y's place. However, they did both change from positive to negatives. So here is that algebraic expression. We have -x, -y. Lastly, we have a 270 degree rotation. This is where that corner would end up. And the ordered pairs that I have this time are 4, -4, and 7. Notice how once again those numbers switched places. Therefore, the y and x swapped. And this time, the value of 4 is what changed. Now that was in the y, so that's why the y value changed. The x value remains the same. So these are our three algebraic rules that we really need to know and understand. This is what they look like all together. Now we've come up with the sticky note dance, and the sticky note dance is going to help us remember these rules. The sticky note dance with our hands, which represent the x and the y, are going to first switch, so y then x, unswitch, x and y, and switch one more time, y and x. So our hands are going to represent the x and y values, switch, unswitch, and switch. Now the only thing you have left to do is memorize where those negative signs are, and you could remember this by stomping your feet. It would be the right foot that stomps, then both feet that stomps, and then your left foot. Another little trick is that 90 degrees is also known as a right angle. So that's another way to remember that the right side, or this x value after they switch, is what's going to be changing or have a negative sign. I'll be posting a video of the sticky note dance shortly, and I hope that helps.